So we begin with question number 1. A discrete random variable x is binomially distributed. That is, x is distributed binomially with parameters n and p, where n is equal to number of trials. P is the probability of success in a trial and q is the probability of failure in a trial. Here it is given the PMF of x. It is given that it is distributed binomially. This is the formula of binomial distribution. So what is given in above statement is given here mathematically. Consider another binomial distributed random variable y, which is again binomially distributed. N and p are the same parameters as given for x, and let x and y be independent random variables. If z is equal to x plus y, then which of the following statement is true for the PMF of z? That is, we have to find out that which of the following is the PMF of z. To all the students, I request you to pause video for 2 minutes here and solve this question, and then only go for solution. So I request you to pause video and solve the question here. So now we will go to the solution of this problem. Firstly, I will begin with explaining what does this mean. This representation is used in this question. I will begin with explaining what does this representation mean. In some in random variables, this is the standard procedure of representing any binomial random variable. By giving this in question, the examiner needs to say that PMF of x sample. This is the random variable capital X, and this is the sample value of capital X, which is denoted by small x. The examiner wants to tell me that the PMF of capital X is MC small x p power x 1 minus p, which is q power n minus x, where small x can take values 0, 1, 2, up to n. So instead of giving this PMF in the question, the examiner may simply say this, may simply use this representation itself in the question. Instead of giving this whole PMF, the examiner may use this representation itself in the question. Similarly, it's given that y is distributed binomially with n and p. So PMF of y in this question is not given. It's given using a short representation. This representation is used. So we can say that the PMF of y similar to x, we can write it is NC y. This n is used here. If these two n are different, n1, here it is n1 and here it is n2, then this n2 will be used here and this n1 will be used here. Similarly, p can be different, but in this question both n1 and n2 are same and p1 and p2 are same. Okay, so similarly we can write p power y q power n minus y, where y can take values 0, 1, 2 up to n. So it is given that z or z is equal to x plus y. We need to find out how is z or z is distributed. We need to find out how is z distributed. By which I mean the question examiner wants to say that you have to find out the PMF of z. This we need to find out. So let's see how to calculate this. So z is equal to x plus y. We know that x belongs to integer values from 0 to n. Similarly, y belongs to set of integer values from 0 to n. Simply by putting the minimum values of x and y, we can see that z will belong to integer values. X minimum value is 0, y minimum value is 0. So 0 plus 0, z's minimum value will be 0. Similarly, x maximum value is n, y maximum value is n. So n plus n, y, z maximum value will be 0 to 2n. So z can take integer values from 0 to 2n. So now we will find the PMF of z. For that, we need to find out probability that capital Z is equal to small z. We know that capital Z is what? So we know the capital Z is x plus y. From here we can write this probability is equal to probability that capital X is equal to small z minus y. From the PMF of X, we know the probability capital X is equal to this. I am writing small x. This is equal to, from the joint PDF of x and y, we know PMF of x is equal to x is equal to summation for all values of y, probability joint PMF of x is equal to x, comma y is equal to y. This is the joint PMF x and y. For two independent random variables x and y, this is nothing but summation over y. Joint PMF is equal to product of individual PMFs. Probability x is equal to x and probability y is equal to y. Summation over all y, probability x, x capital X is equal to small x. Small x, what we are writing small x? Small x is equal to small z minus capital Y for one particular value of y. So here we will write capital Z minus, here what are the values of y? Y belongs to 0 to n. Y belongs to 0 to n. So we are taking one sample value of y here because I am taking all values of y. So here we will take one sample value of y. probability y capital value y is equal to. Now putting the p-maps of x and y, which we know is nothing but nc x p power x. X here is z minus, firstly I will write in terms of x, 1 minus p power n minus x, nc y p power y, 1 minus p power n minus. So putting the value of x, this value of x, small x, in this expression, we get summation over y, all values of y, n c z minus y p raised power z minus y, 1 minus p raised power n minus z minus y, n c y p power y, 1 minus p power n minus y. So this will be equal to summation over all values of y, n c z minus y, and n c y and p power z minus y plus y. So y and y will cancel, only z will be left. Similarly, 1 minus p raised to power n minus z plus y plus n minus y. So 2n minus z. This is independent of y. This whole term is independent of y. So we can take this whole term out of this summation, and only this term will be left in summation. So we can write it, this will be equal to probability that z is equal to z will be equal to p power z and 1 minus p power 2n minus z, and summation for all values of y, y is equal to 0 to n n c z minus y and n c y, where z can take values from 0, 1, 2 up to 2n. Now this term, if we put all these values of z here and calculate it, we will find out this term will be equal to, this term will be equal to 2n c z. This whole term will be equal to this term. So putting it here, we get 2n c z p power z and 1 minus p, which is q power 2n minus z, where z can take values 0, 1, 2 up to 2n, which is nothing but the binomial distribution formula, where total number of events is 2n and parameter is same as p. So we can write that is distributed binomially. This is the formula of binomial distribution with parameters 2n and p. So this is the answer, that is option number, I think it is option number C. So guys, this is it, and I hope you like the level of this question and video solution. So please do like this video, and for more videos and solution, subscribe my YouTube channel and Instagram channel also. The details are given in description.